Hey guys, welcome to day 5 Understanding Relationships in SQL. In the last video, we have built our database and defined tables. We have also understood what are primary key and uniqueness rules. This gave us a clear idea of what is an identity column and how a unique key can be defined in the table. In the real world, the data doesn't live in isolation. An employee belongs to a department, but the department may manage multiple employees. So like that, a department may have number of employees, and in an organization there can be multiple departments. So hierarchy, there can be a hierarchy where we have at the topmost hierarchy we have something called organization. Within that organization you can have multiple departments, like let's say HR, IT, or administration, and within that each of them can have different employees, and it's not just single employee they manage, they can have multiple employees. So if primary keys are about identity, the key by which this relationship is maintained is called foreign key. They ensure that one table can reliably point to another, and together they maintain the data integrity. Why the relationship matter? Okay, let's understand why this relationship matter. Imagine we have two tables, department and employees. Let's just get a visual picture of how my department table look like. So this is my employee table look like. So this is my employee table, and it has employees from different departments. Okay, so my employee is having, let's say these are like employee IDs, they are first names, they are having last name, there is an age column in which age is given, there is a gender, there is salary, and also there is something called department ID, and this represent the department to which they belong. So it can be 1 2 3, but what represent that 1 2 3 we'll see in the next table. There is a higher date as well. So this is a representation of your employee table. Let's understand how my department table looks like. So my department table is having columns such as department ID, department name, location, but this department ID, one represent the sales department, two represent the marketing, three represent HR, four represent IT, and five represent finance. And accordingly, you have like different department IDs present. So if the department ID in front of employee number 111 is 1, it represents that he belongs to sales department. So like that, this relationship is there. So what happens if we don't maintain such relationships is, imagine you have two tables like department and employees. The department table lists all the valid departments in the company, in an organization, and employee table lists all the individual employees. Now if we store department information directly into employee table as a plain text, say HR or finance, the problem is, let's say if tomorrow the name of the department is changed from HR to human resources, we might have to update an entire employee table. Okay, and there is a chance that you may miss it somewhere or the other. If someone types finance by mistake, like two e's are there, you can see, then then there is a problem. Again the relationship is broken. What if the department is renamed later, as I mentioned, right? It can be called HR, but later they may call it like some other thing like human resources, or nowadays there is a trend of calling HR with a different name. Instead of human resources, they call sometime like just resource department or something like that, right? So there, these can change, or even for that matter, IT department they sometime may later call it as like technology department, right? So such thing might happen, but then these kind of updates to the databases are extremely costly. So to avoid such a thing, the better way is to store only the reference in the employee table, like a department ID, and the database enforce that uh, every employee's department actually exists in the department table. So this is a foreign key relation. So for example, if we enter any invalid department, so we see that okay, we have only 5 departments, but if someone enters 6, then there is an error that okay, such department is not present. Again, just a note. So this is the in the context of databases like Microsoft SQL Server or MySQL. This relationship is enforced and put together, that if you define something as a foreign key relation, then if you try to enter, there is a reference validation happens. And if let's say a person tries to enter an invalid department in employee table, while entering the data in the employee table, then the error might pop up. But that might not be true in Delta Lake. So Delta Lake does not honor these relationships. These relationships needs to be honored when you are trying to do this do the coding at Spark, at the Spark level, at processing level. You need to manage that. But recently, as I mentioned in the last video also, they have started allowing to put the relationship, even though it is not enforced. Maybe we don't know, down the line they may start enforcing also, or may give such facility. So in this video, what we'll do specifically is we'll create these two tables. So let's create a employees table and let's insert some data into it. So as I mentioned, employee table is create table if not exist. So create if table does not exist in my particular schema. Three level namespace, as I mentioned in the last video as well, like catalog, schema, and table name. These are the column names: employee ID, first name, last name, email, hire date, salary, department ID, and you are putting a constraint called foreign key department references a particular department ID. So you need to ensure that you create the department table first, and then once the department table is created, you can create the employee table and then add the constraint to it. So I have already created department table, or rather let's create the department table first. Okay, insert into department table. These are the three departments that we are planning to put. So let's before insert sorry let's drop the department table, existing department table, and let's create the department table. Okay, and it has three columns: department ID, department name, and location. The moment we run this, a table will be created. Let's insert the data into department table with insert into departments and then values. These are the three different rows that we are going to insert. Let us see what are the values in the department table. Let me move this up uh, and then quickly run this. So we should be able to see like three rows inserted into the department table: 1, 2, and 3. HR, finance, and IT. Okay. Now let us create employee table. Since employee table has a reference of a foreign key in department, so we have created department first. Now let's create an employee table. Okay, the command says create table if not exist. So sometime what happens is, while preparing these practice exams, I have a lot of places I have to create the table already. So that's why I put this way. Okay, but for showcasing, I am completely dropping this table and creating a new one. Okay, now we'll start inserting the data. We'll insert into the table, and we have supplied all the column names in sequence, and in the same sequence we are passing the values as well. So okay, this is done. First value is done, second is also inserted. So I think I almost inserted 4 rows into it. So you should be able to, so when you do a select on the employee, you should be able to see 4 rows. Yes, we are able to see 4 rows, and department ID is 1, 2, 9, and 6. Like 1, 2, 9, and 6 is, but we only have 1 and 2. This I added additionally just to showcase that Delta Lake, which is available as a free edition on Databricks. Delta Lake, which is a part of Lakehouse basically, and Lakehouse is the heart of Databricks. And since we are doing all these exercises on Databricks, this enforcement is not there. Otherwise, when you would have ran this query, like if first insert, let's check the first insert. So in the first insert, you see the department ID is 1 and 2. So this is valid. This would have gone through. But if you would have been on Microsoft SQL Server, or let's say MySQL, then this enforcement of foreign key would have happened, and this would have given an error. Okay, and finally we get like everything. Select start from the employees. We can see 1, 2, 3, 4 employees there. Okay, so these are the four different things that we have. Okay, so what we have understood today in this video is what is the real world relationships between the data sets, how they are maintained. One of the important relationship that we have understood is the foreign key. in Delta Lake it is not constrained, but maybe they have started allowing to define. Maybe in the future we may start enforcing. We may see that Databricks give some feature where we start enforcing as well, but right now it is not being enforced. But yeah, so this is how it works. And let me just tell you, maybe this is what my understanding is. The reason why these enforcements are not there is, when we are dealing with Databricks, uh, we are dealing with Delta Lake, and Delta Lake is end of the day a big data lake house, right? It's a lake house, and even though we may be working with very small tables, but in reality, a table might contain millions and billions of rows. So if you start enforcing something so strongly and quickly, then it may trigger lot of checks and things which may delay a lot of other things. Like for example, if you try to insert a row and every time it has to go and check with millions and billions of rows, then it is very difficult. So for now they have started defining it, and we, as I mentioned earlier as well, we maintain that when we try to do the uh, compute level, like Spark transformations and all. Okay, so thank you guys for listening into this. This is the day 5 of understanding SQL relationships between the table. This is one of the most important concepts. So what you should do is think of your organization. If you're working, or for example if you're studying, you can consider a college as an org, and within that org there are like different department and there are different students. And student, you may combine it into one table. There might be teachers, employees, teachers who are the employees. So employees can be one table, student can be one table, but there will be common table called department, because a teacher is a part of department and an organization. So this way, this kind of relationship you should read out and practice yourself, because as I always mentioned, getting the data right is the first step. If your data is not correct, then leave your AI and other stuff. If the data is not in a right relationship, not giving the right insights, then you are done. You will not be successful in creating the right insights and AI. Okay, so if you want to go up to the AI and insights layer, you need to understand this relation and put this data in a right frame. Okay, so thank you guys for listening into this. Please do subscribe.